Today we will discuss about reciprocal network, and we will deduce the condition in terms of z parameter so that a network will be reciprocal. So first of all, we should know what is the definition of reciprocal network. Now suppose we take a two-port network and I apply a excitation in this port. This is called excitation, and we will get the response in this port. So for specific excitation we get the response in this network. Now the network is said to be reciprocal if the ratio of response to excitation is same for interchanging the position of excitation and response. That means if I interchange the position of excitation and response, at that time the ratio of response and excitation must be same. So then this type of network will be reciprocal. Okay, so a network is said to be reciprocal if the ratio of response to excitation is same for interchanging the position of excitation and response of a network. Now we will deduce the formula in terms of z parameter so that a reciprocal network must hold this formula. Okay, suppose this is a network, and in this network this is excitation, and suppose this is current I1 and this is current I2, and for this excitation we get the response I2 dash. So from this response terminal we say that I2 must be equals to I2 dash. Okay, because this current and this current are opposite in direction, so this must be equal and opposite sign. Now this two-port network can be represented in terms of z parameter. So in this port we can write that Vs must be equals to Z11 I1 plus Z12 I2. Now this I2 is equals to minus of I1 I2 dash, so this equation will be minus Z12 I2 dash. This is equation 1. Now in this port this is short circuited current through this, so here is voltage is 0, so V2 equals to 0 equals to Z21 I1 plus Z22 I2. Now I2 is equals to minus of I2 dash, so it will be 0 equals to Z21 I1 minus Z22 I2 dash. So from this equation we can write that I1 equals to Z22 I2 dash divided by Z21. This is equation 2. Now from this equation we can write that Vs equals to Z22 and this is Z11 into Z21 into I2 dash. I put this value of I1 into this equation 1. So this is Z11, so Z11, this is Z22 by Z21, this is Z22 by Z21 and this is I1, so here it will be I2 dash. Now minus Z12 I2 dash. So from this equation we can write that Vs is equals to, this is I2 dash is common, so I2 dash into this term will be Z21, here will be Z22 Z11 minus Z12 Z21. Okay, now from this equation we will get I2 dash divided by Vs can be written as Z21 divided by Z22 Z11 minus Z12 Z21. This is equation suppose 3. Equation 3. So if I apply the excitation in this port and we will get the response in this port, then the ratio of response to excitation is given by this equation. Okay, now we will interchange the position of excitation and response. Okay, so here I will interchange the position of excitation and response. Okay, so here we will apply the excitation, that means Vs. Okay, and we will get the response here, so I1 dash. So this is, in this case, here is excitation and we will get the response here. In this case we can also write that I1 is equals to minus of I1 dash. Okay, so in terms of Z parameter you can write this is voltage 0, so 0 equals to V1 equals to 0 equals to Z11 I1 plus Z12 I2. From this equation we can put this value of I1, so it will be minus Z11 I1 dash plus Z12 I2. So from this equation we can write that I2 equals to Z11 divided by Z12 into I1 dash. So this is equation suppose 4. Now in this port we can write another equation in terms of Z parameter. So it will be Vs must be equals to Z21 I1 plus Z22 I2. Now Vs will be, this is I1, okay, so I1 can be replaced by minus I1 dash, so it will be minus Z21 I1 dash plus Z22 I2. Okay, now we will put this value of I2 in this equation. So here this is Vs, so minus Z21, this is I1 dash, this is plus, this is Z22, so here Z11 and here is Z22 divided by Z12 and here will be I1 dash. Okay, so you can write that Vs equals to, you can get common I1 dash, so I1 dash into this term will be Z12 and here it will be, this is positive, this is negative, so you can get first this term, so Z11 Z22 minus Z12 Z21. Okay, so from this equation you can write that I1 dash divided by Vs, this is I1 dash by Vs, must be equals to Z12 will be here Z12 and here will be Z11 Z22 minus Z12 into Z21. This is equation 5. Okay, if I interchange the position of excitation and response, then the ratio of response to excitation is given by equation 5. Okay, now we will apply the condition of reciprocal. So a network is said to be reciprocal if the ratio of excitation to response, the ratio of response to excitation must be equals to equals. So this must be equal. So from equation 3 and 5 we can write that Z21 divided by Z22 Z11 minus Z12 Z21 equals to Z12 divided by Z22 Z11 minus Z12 Z21. So this term and this term are equal, so this will be cancel out. So Z21 equals to Z12. So this is the condition that a two-port network will be reciprocal if the Z21 equals to Z12. So in terms of Z parameter, you can say that a network will be reciprocal if the Z parameter Z21 must be equals to Z12. Okay, this is the condition for a circuit to be reciprocal